analysis method, we can find the current in the various arms of this circuit. The first step in the node analysis method is to identify the nodes we have. Node is where at least the 3 wires they are connecting. So 1, 2, 3. So this is a node. This is a node 1, 2, 3. This is a node. This is also a node. Once we have identified the nodes, the next step is to give a reference potential to any of the nodes. Over here we can give reference potential to any of the nodes. Let's say we take this at 0 volt potential. We are giving it a reference potential. So once we take it at 0 volt, so this is going to be 0, so this is going to be minus 10 volt. So this is going to be at minus 10 volt. We have this node also, and we can take it as, let's say, at X potential, and we can take it as at Y potential. Once we have taken this as X potential and this is Y potential, and then we can use Kirchhoff current laws. Let's say we can say, for this if we say, this is I1, this way is I2, and this way is I3. Generally, when we use Kirchhoff current law, that is I1 plus I2 plus I3 etc. is equal to 0, we assume this node to be at the highest potential or lowest potential. That is, we assume that is all the currents they are moving away from this node, or they are moving towards this node. So over here we have assumed that this is at the highest potential. So I1 plus I2 plus I3, they are moving away from this junction or node. That is I1 plus I2 plus I3 is equal to 0. So nodes we have identified, we have given a reference node also, and we have to the other nodes, we have taken the potential at X and Y. Now we use KCL, I1 plus I2 plus I3 is equal to 0. And the next step is directly using Ohm's law, that is V is equal to YR, we can replace I in terms of V, that is potential difference divided by resistance. So I1 is, this is at X, if this is at Y, so this is at Y plus 20 volt. This is at Y, this is at a higher potential, so Y plus 20. So across the ends of the resistor, this is at X, this is at Y plus 20. Current is moving in this direction from higher potential to lower potential. So potential difference is X minus Y plus 20. That is a potential difference. V is equal to YR. So this implies I is equal to V by R. So this is V divided by R 5. So this is I1 plus, when we talk about I2, so this is X minus 10 divided by 5. So this is I2, and I3 is plus I3, that is X minus 0 upon 10, that should be equal to 0. So this is one equation. If we rewrite over here, so it is X minus Y plus 20 by 5 plus X minus 10 by 5 plus X minus 0 by 10 is equal to 0 if we rewrite over here for the X node. And now similarly we can write the equation KCL for the Y node also. So we take this as, let's say, I4, I5 and I6. So I4 plus I5 plus I6 is equal to 0 for the Y node. Now we remove this, so that we remove I1, I2, I3 so that we don't get confused. So if this is Y, so this is Y plus 20, and this we have taken at X. Current is flowing in this arm in one direction only. So the value of I4 is Y plus 20 minus X, that is potential difference across the ends of the resistor, divided by 5 plus I5, this is at Y, this is at 0, so Y minus 0 upon 5 potential difference by resistance, and this is Y minus plus Y minus 10 potential difference by 5, that should be equal to 0. We have two equations and we have two unknowns X and Y. We know how to simultaneously solve these equations. We solve these equations to get the value of X and Y. Once we get the value of X and Y, we can easily find the current through any of the arms in this circuit. Values and X and Y which come out after solving these two equations that I have is X comes out to be 16 by 13, Y comes out to minus 10 by 13, and the current through 5 ohm resistor through this resistor is obviously this minus this, that we put y minus minus 10 by 5, that comes out to be 24 by 13 ampere. You can solve it and you can check the values for yourself.